In this video, we are going to combine the two ideas of evaluating a function for a given x value and solving a function for a given y value. So let's take a look at this absolute value function that we have, g of x. It's equal to the absolute value of x plus 2 minus 5, and the graph looks like this. The first part says find the value of g of negative 6. If we look at the graph, we could find this answer. If we substitute negative 6 in place of x, we would get a certain answer, which we will see. Or we could just look at when x is negative 6, what is the y value on this graph? And it appears that when x is negative 6, the y value should be negative 1. Let's see if that happens. Let's take this function g of x and let's substitute negative 6 in place of x. So we put a negative 6 where the x is. The first thing I will do is what's inside the absolute value bars, which is to add negative 6 plus 2, and that will give me negative 4. Next, I will take the absolute value of negative 4. The absolute value of negative 4 is 4, because negative 4 is 4 units from 0 on a number line. Finally, I'll subtract 4 minus 5 and get, you guessed it, negative 1, just as we suspected we would get, negative 6, negative 1. Pause this video and see if you can find the value of g of 1. Well, if you look here at this graph, when x is 1, we expect a y value of negative 2. Let's see if that happens. Yes, indeed. If you substitute 1 in place of x in the function g of x, 1 plus 2 is 3. The absolute value of 3 is equal to 3 because 3 is 3 units from 0 on a number line, and 3 minus 5 is negative 2. See how that differs from the next two problems. Here we substitute a value in for x and solve for y. In these next examples, we're saying g of x equals negative 4. We're saying the y value is negative 4. What are the x values? Once again, I could do a little cheating and just kind of look at this graph and see that when my y values are negative 4, I'm going to get an x value of positive 3 and negative 1. Let's solve it and see. For this, you're going to take your function g of x and you're going to set it equal to negative 4. And then solve your equation. So here we're simplifying, here we're solving an algebra problem. I'll begin by isolating my absolute value bars. I will add 5 to each side of my equation. And when I add 5 to negative 4, I get positive 1. You might have forgotten how to solve an absolute value equation. Think of it like this. This equation says that some number, x plus 2, has an absolute value of 1. That means that this number, whatever it is 1 unit away from 0 on the number line. Well, there are two numbers that are 1 unit away from 0 on a number line. That's 1 and negative 1. So when we solve this, we take our number, x plus 2, and we say that number must be 1 or negative 1, giving us two equations to solve. They're not difficult to solve once you remember that that's what you're supposed to do. Subtracting 2 is going to give us negative 1 in the first equation and negative 3 in the second equation. So to answer the question, when y is negative 4, what is the x value? Well, the x value might be negative 1 or negative 3. As we saw here, when the y value is negative 4, the x value might be negative 1 or it might be negative 3. See if you can pause this video and use the same steps to solve this next example. How did you do? Let's take a look. If you use the same steps, you set the function equal to 5. You add 5 to each side to get 10. Now you have your absolute value isolated. This is where you split it up. Some number, x plus 2, is 10 units from 0 on a number line. That means that number, x plus 2, is either 10 or negative 10. When you solve by subtracting 2 from each side, you get 8 or negative 12. So when you have a y value of 5, your x value is 8 or negative 12. We can't verify that precisely on this graph, but if you think about this extending, it's not too far-fetched to think that if you went out to negative 12, the y value would be 5. And if you went out to x equals 8, the y value might also be 5. Let's take a look at another example. Let's look at this square root function h of x. Find the value of h of negative 1. That means substitute negative 1 in for x into the equation. And then follow your order of operations to simplify. Negative 1 plus 6 is 5. And then I used my Desmos calculator, my scientific calculator, to type this in and get an approximation, hence the wavy equal sign. The square root of 5 is an irrational number. That's a decimal that never ends, but I can approximate that. Let's see if that matches our graph. When x is negative 1, my y value is somewhere between negative 1 and negative 2. So this negative 1.5 is a nice approximation. What about when h is 10? Again, we just substitute 10 in place of x, follow our order of operations. 10 plus 6 is 16. The square root of 16 is 4. Negative 2 times 4 is negative 8, and negative 8 plus 3 is negative 5. Unfortunately, we can't verify this with the graph, but it's not unreasonable to think that if we went out to an x value of 10, the y value might go down to negative 5. Again, these next questions are asking the opposite. Now we're saying the y value is 1. What is the x value? So here we're going to take our function and set it equal to 1. And then we solve the square root function. We begin by trying to isolate the square root by subtracting 3 from each side. And 1 minus 3 is negative 2. I'll further isolate the square root by dividing both sides by negative 2. And negative 2 divided by negative 2 is 1. Now I'm ready to get rid of the square root sign. How do you get rid of a square root in an equation? Well, you do the opposite of square root, which is squaring. So I square both sides of my equation. By squaring the square root of x plus 6, I simply eliminate the square root sign because squaring is the inverse operation or opposite of square root. When you square 1, you still get 1 because 1 squared is 1. Now I can subtract 6 from each side and get x equals negative 5. Let's see if this shows up on my graph. Let's see. The h of x equals 1 means the y value is 1. When the y value is 1, the x value is negative 5. See if you can follow that pattern and answer the next question. How'd you do? Let's see. If you set the function h of x equal to negative 3, following our steps, we subtract 3 from each side. We divide by negative 2. To get rid of the radical sign, we square both sides. This time 3 squared is 9. And now we subtract 6 and get 3. Again, let's see if this works out. The y value is -3, and the x value is 3. Hope this helps.